Hello, everyone. Welcome back for another math lesson with Mr. Hopkins. Today we're continuing with the last lesson in the unit. It was the second half of more modeling with linear functions. We left off on number 4. So it says biologists estimate the number of deer in Rhode Island in 2003 was 1,028, and in 2008 it had grown to 1,488. Biologists would like to model the deer population P as a function of years T since 2000. So 2003 since 2000 would actually be 3, and 2008 would be 8. It says calculate the change in population over change in years, time, from 2003 to 2008, include proper units. So whenever you're given a question like this, I can go ahead and make ordered pairs. So 2003 and 1028 would become 3 and 1028. The other ordered pair would be 2008 is represented by 8 and 1488. So we can pull ordered pairs right out of the context of the question. And then we're going to use the change in y over change in x, which in this case is the change in p over change in t. So don't let the letters scare you too bad. So let's see here. Change in p over change in t. Subtract the y's, and then subtract the x's. So when you subtract these, you get 460 over 5. And using a calculator, you get 92. So it says include proper units. So this is 92 deer population, or 92 deer per year. And again, this is since the year 2000. So determine algebraically how many deer this model predicts were in Rhode Island in the year 2000. Well, if we go back up to the top of this where it says since 2000, that would be the starting point. So when we talk about linear functions, y equals mx plus b, the b is the starting point. That's the y-intercept. So that's what it's asking us to find. Now I can use either of the 2 points up here for my x and my y. And I already know this is my slope, the m, so I can plug them into the equation and solve for the y-intercept. So let's just do that. Our y is 1,028. Our slope is 92. The x is 3. And we're solving for b. $276. So b would actually equal 1,028 minus 276, 752. So in the year 2000, there were 752 deer estimated. And it says write a linear equation for the deer population P as a function of years since 2000 T. So P of T equals our slope plus the y-intercept. So there's our equation. And how many deer does this model predict for the year 2021? Well, it actually says for this year. So we need to plug in 21 for T. So multiply these, we get 1,932. So 2,684 deer this year. Okay, number 5 is going to be set up the same way, where I can take ordered pairs right out of the context of the question. So as Evan is driving her car She notices that after 1 hour, her tank is 7.25 gallons full or left. And after 4 hours of driving, it has 3.5 gallons left in it. So find the slope of these 2 points. So again, I would have 1 7.25 and 4 3.5 as my 2 ordered pairs. So if I did change in y over change in x, or in this case, let's say change in gallons over change in time, we'd have 3.5 minus 7.25, 4 minus 1. So what do we get here? You get a calculator. Negative 3.75 over 3. So negative 1.25. And with the proper units on this, so that would be gallons per hour. All right, assuming the relationship H and G is linear. So again, linear, we should be thinking y equals mx plus b. Find an equation for G in terms of H. So I already have the slope, which is this up here. What I'm missing is the y-intercept. So once again, plug one of these points in for x and y. 7.25 equals my slope, negative 1.25, times 1 plus b. Well, anything times 1 is itself, so that's negative 1.25 over here. So to get rid of it, let's add it. And I get b equals, let's see here, 8.5. So if that's 8.5, we need the equation. So G in terms of H. So G of H equals our slope, negative 1.25 H, and the y-intercept is 8.5. Phew. Okay, according to this equation, after how many hours of driving will Evan run out of gas? So if I set this equation equal to 0, and solve for H, that'll tell me how many hours. Because I want to find out when it equals 0, or gas, that is. And then I'm going to divide, oops, I left my H off. Divide by negative 1.25. And H equals, calculator time, 6.8 hours. So there you have it. We have some real life situations with the math that we're doing in school. So if you have any questions, please reach out. I look forward to seeing you again.